Okay guys, to understand further on the theory in operation, we go back to the previous earlier notes that I have given to you all, that we discussed before. Okay, if you take a look at this note, so we have gone through this note before. Actually, correction please, here is not right hand rule, it should be a left hand rule, because for this theory, a current that carrying a wire in the presence of a magnetic field, we have a force induced on it, so it should be a left hand rules. You see, if you have a left hand rules, the left hand fingers, so this is your finger, this is your thumb, okay, this is your magnetic field, which is B, so this is your current of I, and this will be your force. And so you have B on this direction, you have I on this direction, so this plus means that if we see the arrow from behind, so we shall see the plus sign. If we see the arrow, this is your I, from in front, we shall see the dot sign. So this is the plus signs, means that you will see the magnetic field, and magnetic field from behind. So the field is going to your finger, index finger. So this is I, and I going to move to the left, so your force will be upwards. So it should be a left hand rules, okay, not a right hand rules. So this is applicable for a motor, and motor you use left hand rules. Meanwhile, for generator will be right hand rules. You have a generator, so it should follow right hand rules. The force will be upward. This is the arrow or side of your magnetic field, so this is will be your current. So this is for generator using right hand rule. Meanwhile, your motor you use left hand rules. So if you see on the next slide of the previous note, so this is your generator, so this one should follow the right hand rules. And your finger here, this is your thumb, this is your magnetic field, so this is your current, and current, your field, and this is your thumb. The force is moving, if you have the force upward here, so you will generate the current to the upper side. And so you put your right hand rule here, right hand rules, you put your right hand and to the from north, and from north to south the magnetic field. So you have a force, and you move this rod to the right side, so the force to the right side, you have your B in front, but now it's upward, so in front, so you have your I and moving upwards, means that you will generate voltage in terms of from bottom to top, and V positive here, V negative here, so the current will move to the upwards. And instead, if you put your right hand from north to south, your force is from center to your right plane, so the current will flow from bottom to top. Okay, this is applicable for generator, and right hand rules for generator. And so please bear in mind, you have to remember, and right hand rules for generator. Meanwhile, your left hand rules for motor. Okay, then when we go back to another slide, previous slide, we can see that if we have a current carrying wires, let's say it's moved to the top, so there will be a flux. which generate around the wires. So this is will follow the right hand grip lah, and right hand grip and RHG. So if one wire you have a few amounts of flux, but if there is a wire, same wire, you loop together, so the flux will be built up. And let's say if one wire will produce one flux, so 2 wires, 2 flux, 3 wires, 3 flux. If you loop it in 10 wires, it will be 10 flux here. So the same, the flux will follow the same direction. Let's say we have here current moving upwards. So the flux, if you grip over here, so there will be a flux that moving following the right hand grip and right hand grip. So what happens is that when you mount or you put the wires and around the core or magnetically conducted core, so you will build a flux. And sorry, this is the wire, let's say this is the wire, and so you build a flux, and which will is north south, which we build around the core itself. And so it will be flux that moving upwards like this. And so here is actually the north and this is south, and it's not the other way, but it is north, because the flux will come out from north pole and return back to south pole. Same like our globe. We have a globe, means that our earth here, and this is Malaysia, and you have Malaysia here. So this is north pole, this is south pole. So the magnetic field actually will flow upwards down here, and so this is the arrow of your flux. So this is north, this is your south. Okay, so let's say you have a wire that flows a current, you round into the one core and magnetic core, magnetically connected core, so you have a flux. More windings, more flux you will generate. So this is north, this is south. Okay. Okay, then if there is a 2 pole, so let's say you were building 2 poles using the same wire, which is come out from here, and then you rewind into another pole, so you will create another what's so called pole of north and south here. So this pole also will have another flux with the same identical amount of the above pole. So we have here south pole, north pole. And then if you have a conductor squirrel cage here that used inside our rotor, and this squirrel cage actually how it looks like, as we mentioned inside the notes. So if you refer back to the notes, it seems like the squirrel cage is built or constructed just same like this hamster cage. Actually, it's not a squirrel, it's a hamster, and so a rat or a guinea pig or a hamster actually. So you have a bar which interconnected at the end of the section. Another section also be interconnected. So this is the current carrying bar, and usually we build construct using aluminium and or copper, but with copper the current carrying is too high, so you might have a issue of high starting current. So usually they made out of aluminium. So in actual station, you can see it was like this. You have a ending interconnected aluminium mold. So this, the in between here is a aluminium conductor bar actually. So it made in skew, so it twisted a little bit to avoid in terms of noise and what's so called a hiccup or a non-smooth rotating of the rotor. Okay, this is how it made if we view in terms of 3D view. But when we assume that if we view from the side view, so this will be the conductor bars lah, the conductor bars. So means that we are looking from the side view of the rotor construction. So we assume we have two poles here. The first will build as south pole to face the rotor conductor bars. Another poles will have a face of north. So both pole will create a new flux line of instead of it returns back here, the flux will travel all along to south pole. And so this is the arrow or the field direction right now. So if you write, this is the motor, is it? So if you write your finger like this, you have your thumb is moving to the left. This is your field B and moving to upwards. So if you have your current and moving to the left, and means that you have a current moving into the pole, into the plane. So you can see from here, let's say the plus sign, and here we have a plus sign. So means that you shall have a force to the left or to the right. Now you put your left hand on the plane, you put your arrow of your field upwards and your field upward. So your current moving into the plane, so your force means that the force which push your bars here is moving to the right. And so this is the arrow of where the rotor will turn, and so it will turn clockwise and clockwise, not anti-clockwise. It will turn clockwise. So if you refer back to your notes, you can see here, if we put our right hand grip here, so we shall have our flux that will move, into the poles and into the poles. So it means that the flux will move into the poles, right hand grip, and it moves here. So you have flux which move into the poles. So when the flux move like this, so it will generate a north pole here and it will be south pole over here. So same goes to another interlink of iron core poles. So here will be your north, here will be your south, because the flux will travel upwards like this and will go out here, in here. But when you interlink both flux, so the flux will travel upward like this. And so this is the arrow of your flux. We travel from north to south. So if you apply your left hand rules here, so what happens is that when the flux traveling upwards, so your thumb is like this, your iron bars here will conduct current into the plane. So where it should turn, to the left or to the right.